Hi Prof, we are from Syntx with A. Our group will be presenting about optimistic locking. I'm Nilofar. My groupmate Wei Jing will be talking about advantages and disadvantages of optimistic locking and how database supports it. Felicia will be demonstrating an example of optimistic locking, while Jolene will be talking about pessimistic locking, and Felicia will be demonstrating an example of it. So what is optimistic locking? Transaction isolation is usually implemented by locking whatever that is accessed in a transaction. However, with optimistic locking, a resource is not actually locked when it's first accessed by a transaction. Other transactions are able to concurrently access to the resource, and hence, there's a possibility of conflicting changes. So how does optimistic locking works? Optimistic locking involves 4 phases. First, the transaction beginning is marked by recording the timestamp. Then, modification is done whereby the database values are read and changes are written tentatively. Validation occurs by checking whether the other transactions have modified data that this transaction has used, read, or written. This includes transactions that was completed after this transaction's start time, and optionally transactions that are still active at validation time. Finally, if there is no conflict, the changes will take effect. If there's a conflict, the changes are resolved, typically by aborting the transaction.
So how do databases support optimistic locking? Firstly, optimistic locking is most applicable for high-volume systems, and it will be a 3-tier architecture where the connection to the database for a session is not necessarily maintained. Clients are also unable to maintain these database logs, as the connection to database will actually be from a pool. In other words, the client will not be using the same connection for each access. In this way, this implementation with optimistic locking can actually guarantee the record in the database that it will not be changed between the time it was being read and the time that it was written. This will definitely protect the integrity of the database. Coming to the advantages and disadvantages, for the advantages, it prevents users and applications from editing the stale data and notifies users of any locking violation immediately when they are updating the object. It will not lock up the database resource as well, so that others are still able to see the content of the database. Lastly, it prevents any database deadlock. A deadlock is actually a situation in which 2 or more transactions are actually waiting for one another to give up the logs in the database. The disadvantages of optimistic locking is that it's unable to prevent applications from selecting and attempting to modify the same data. So for example, when 2 processes are actually modifying the same data, the first one that commit the changes or save the changes will succeed, while the next one will actually fail and receive an exception.
Okay, so the example that we'll be going through for optimistic locking is of Zalora. So Zalora is an online retail store in Singapore. So how they use optimistic locking, we'll be demoing it through a video. So in this video, you can see that the user that logged in was Felicia, and she looks for this dress called a collection ruffle dress. So for the size that she's looking, there's only one quantity of this dress left in the stock. So she will still be able to add it to her bag, which is what she will do. So she views her bag, and so it will be in her cart. So what we're trying to demo is that even though one user has already added this into the cart, access to this particular item will not be restricted for another user. So in this second video, we see that Nilo is logging into her account and she's finding the same dress. And we can see that she will still be able to add this into her cart even though the quantity is still 1. And it's also currently in Felicia's cart. So in this case, the exception occurs when, for example, if Felicia were to actually purchase the dress, that's when the stock would actually change, and then Nilo will receive an error notification to say that there's no more stock for that dress that is in her cart. So this is an example of optimistic locking in the real world. So we will now move on with our presentation to talk about pessimistic locking.
So the opposite of optimistic locking is pessimistic locking, in which the resource is locked from the start to the end of the transaction for the user's exclusive use until he or she is finished with it. It needs either a direct connection to the database or an externally available transaction ID that can be used independently of the connection. In summary, in this locking, if a user wants to update data, it locks the record. Until then, no one else can update it. We have a few advantages and disadvantages of pessimistic locking. The first advantage is that it prevents users and applications from editing data that is being or has been changed. And it also provides an immediate notification of locking violation. rather than knowing it only after the transaction is completed. However, it decreases the concurrency of connection pooling when using the server session, thus affecting the overall scalability of the application. It also requires the maintenance of an open transaction and database lock for the duration of the transaction, which can lead to database deadlocks. Last but not least, it consumes extra database resources.
So the example we're going to use will be Golden Village, GV, one of the movie theatre operators in Singapore. So how the company actually uses the pessimistic locking is on their seat selection page, where two users actually select the same seats for the same movie, same time, and also the same location. So the next two slides will actually show a demo on how the two users encounter the pessimistic locking. So on this page, the user log on to the GV website and then select the cinema, the movie, the date and time. So this will actually bring them to the seat selection page. So in this case, the user actually select the first two seats on the left, row A, nearest to the screen. So after selecting the seats, they will actually choose the ticket type and also the payment mode. And this will bring them to the checkout page. So in the midst of checking out, the next user actually log on to the G website, entering the same detail with the same movie, date and time and cinema, as shown in this demo. So once they select all the conditions, you'll bring them to the seat selection page. As you can see on this page, the first two seats is actually highlighted in purple, which means it's being blocked. This is because the previous user is still in the midst of checking out. So this is one of the examples that shows pessimistic locking. So in order to unblock the seats, there's only two conditions. The first one is where the user actually cancelled the booking by themselves, or the user exceeds the specified blocking duration. And with that, we've come to the end of our presentation. Thank you.